Good afternoon, my name is Bruno Arias Lierde. I'm a Tremuri project expert in S.T.A, and for the video of today, I'm going to make a comprehensive presentation of the local verification module inside of Tremuri. The local verification environment within the Tremuri software is a powerful tool designed to facilitate the meticulous design and verification of various structural elements. It allows to verify multiple elements such as beams, floors, columns, footings, walls, arcs, and many more. One of the key advantages of the local verification environment is its versatility. Whether you're working on a new project or refining an existing design, the software enables seamless integration with the broader structural model. This means that changes made within the structural environment can be instantly reflected in the local verification environment, ensuring consistency and coherence throughout the design process. As we see on the screen, the local verification environment can be accessed by clicking on the Local Verification tab on the Tremuri software. Once we click on the tab, we're going to see that the screen is going to be divided into two. On the right side of the screen, we're going to see a 3D view of our structural model that we just made in the structure environment. And on the left side of the screen, we are going to see the details of the different elements that we want to verify. As we see here, the toolbar in the upper part of the screen is going to allow us to select which elements we want to verify. Regarding beams, we're going to have the option to verify reinforced concrete beams and steel beams. Regarding reinforced concrete beams, we're going to have different options to create a reinforced concrete beam and to later verify it. First, we're going to see that we can create a new reinforced concrete beam with different parameters from the one from the model, or we can also import a reinforced concrete beam that has already been input into the structure environment. So as we see here, for example, we have two different options of import. We can include all reinforced concrete beams that are located on the model, or we can just include all the reinforced concrete beams that have no rebar definition to define the rebars that are going to be used on this beam exactly as we want it. To begin, we're going to input a new reinforced concrete beam. This is going to be a beam that is not connected or doesn't retrieve information from the structural model. So as we see here, when we introduce a beam, we are going to have the option of give it a name, give it a type of structure. It can be new or existing. We can set the constraints that in this beam is going to have, and we can set the different spans of the beams. So we are going to choose different materials from the concrete, the steel rebars, the type of section. We can just choose a predefined section, or we can just set a new one. And most importantly, we are going to define the span of the beam. In this case, I'm going to use just 5 meters of span. Once we click in OK, we are going to see that the screen in the upper part is going to be divided into 3 columns, that it's going to set a list or simple table of all the beams that we have to calculate, the beams that have been already calculated, and the ones that we have declared as completed. As we see here, for each beam, we're going to see the given name of the element. We're going to see which level is going to be associated with, if it was created by the user, if it was imported from the model, if it's new or existing, and the status of the different verifications. As we see here, because this is not yet calculated, we are not going to see information in that aspect. In the lower part of the screen, we're going to see the elevation view where we can introduce different types of loads. As we can see here, we can just add self-weight of the structure. It's going to retrieve that information from the cross-section and the material introduced on the beam. Or we can also introduce another different loads. We can add them, edit them, also delete them, or we can add punctual load, a specific load in a certain part of the span. So for this case now, if we want to calculate, we just go ahead and drag and drop it into beams calculated, and the program is going to calculate it automatically. As we see here, now we are going to see that the reinforcement area is going to be visible. And in this part, we're going to see a suggestion of the rebars that we can use to verify this beam, the minimum rebars that this beam with this certain type of load is requested. So as we see here, we can see a floor plan with the different types of rebars, the dimensions, the length of each rebar, and of course the stirrups and their spacing. Also, we are going to be able to see the different diagrams by selecting the allocated icons. We can see the forces, we can see the verification for the ultimate states, we also can see stresses, deflections, and cracking, which is specific for concrete elements. So as we see here, we have all these options. If this is the case of a new beam, but for existing beams made in reinforced concrete, we have the option of introducing reinforcements such as jacketing for columns or carbon fiber reinforcements for beams and columns. Once we decide that it's done, as we see here, we see the safety factor is bigger than 1, so we can just drag and drop it into the completed section. When an element is on the completed section, what we're going to see here, it's a DXF drawing with all the specifications of the rebars and the dimensions of the beam of the element that we just calculated. We see it's a drawing of the cross section and the length, everything drawn to scale with all the rebars, the stirrups, and their dimensions. For the case that we want to import a reinforced concrete beam, we have different options on how to do it. First, we can just select from the menu to include it from the structural model. That's what we're going to do now. And as we see here, the program automatically retrieves all the information from that reinforced concrete beam from the structure environment. We have that option, or also we can just use our 3D view of the model and just right click on an element to calculate it. As we see here, we can, because it has already been inserted, we can just modify it. Otherwise, we can just calculate it by right clicking on the element. So once we have the reinforced concrete beam that was imported for the model, as we see here, it imports all the information, all the geometry information, the rebars, the materials, and also all the loads that are acting upon this beam, as we see here. And with that, we just simply drag and drop it into the reinforced concrete beams calculated. And as we see here, we see an M that this beam was created from the model. It's new. The flexural verification is passed. The shear verification is passed, but the service verification is not passed. And as we see here, we are going to see a safety factor indicating how far are we to verify this specific element. And as we see here, once we hover our mouse over the exclamation mark, we're going to be able to see a tooltip with information, more information about what is the specific failure in this case. So we see here the stress on the beam is not verified. In this case, we can introduce different, because this element is new, we can just change the rebars of the element. If this were to be an existing element, we could introduce carbon fiber reinforcement on different types of the beams to ensure that it's verified. As we see here, we're going to see the elevation view with all the drawings of the rebars, the syrups, and the diagrams that we want to see. And if we just want to see the drawings of the rebars, we just deactivate the allocated icon. For the case of steel beams, the procedure is going to be quite similar. As we see here, we're going to have two options to introduce a new steel beam or include all the steel beams that are located in the model. When we do this, we just click and select it. We are going to see that automatically the program is going to load the 3 columns for steel beams, all the information regarding the beam, and as we see here, we're going to be able to just drag and drop it into the allocated area. As we see here, all the loads were imported from the structure environment, and the specific verifications for steel are going to be different. And we see here we have flexural and shear verification, and also buckling, which is specific for steel elements. So we see here, we can just go ahead and click on verify. And of course, we can if we want, we can see more details on the results by clicking in this icon over here. It's going to show us more details on all the parameters that were used. Also, of course, especially with steel elements, we can change the computation parameters that are going to be used on the verification, and also by right-clicking on each one of these elements, we're going to open up context menu with more options, such as open to change different parameters of the beam, open the computation parameters. We can also duplicate and delete, and more options to make sure that if we have a long list of elements, if we want to organize it, we can also do it. And so as we see here, we're going to open it, and here you can see all the calculation parameters that are going to be used on this specific beam and the geometry of the materials. As we see here, because this beam was imported from a model, all the parameters that are regarding the materials, the section type, the geometry, they cannot be changed. So I'm just going to go ahead and close this window and go ahead and the verification. Which this environment allows us is to simply just navigate between calculate and calculated, because in the case that we want to change some parameter, we want to change the geometry, we can do that very quickly. Regarding the floors part of the local verification environment, as we see here, if we open the context menu for floors, we are going to have 4 types of floors that we can verify. As we see here, we can have all the types of timber floors that can be one-way timber floor with single wood planks, with overlap wood planks, or with the concrete topping. Also, we have the steel beams and bolts calculation, the concrete brick floor, and the corrugated sheet with a simple sheet or with a concrete slab. As we see here, we have the option of insert a new one right here by selecting one of these options, or also if we have this element on the model that we constructed in the structure environment, we can just right click on the floor and then click on calculate. that is going to allow us to calculate this specific type of floor, and it's going to import all the data from the structural model. In this case over here, as an example, I'm going to show if we introduce a wooden floor, we just introduce the name, we select the type of floor that we want to introduce, and of course we're going to introduce all the parameters of this floor. What I'm doing here is just introducing all the data in this case, and we're going to introduce very simple loads in this case. Perfect, and the combination factor, and then we're going to just click on calculate. As we see here, the program is going to calculate all the verifications for this wooden floor, and as we see here, everything is satisfied, and the final result is satisfied. So we click OK, and our wooden floor is going to be created. In this case, for this type of floor, it's going to create a simple card with just the information if this was created from the user or imported from the model, and if the verification is satisfied or not. In the case, for example, of a concrete brick floor, we are just going to, in this case, we're going to create a new one. And as we see here, the structure of this local verification tab is going to be very, very similar to the ones of reinforced concrete beams. As we see here, we can choose the different types of structure, and of course, all the geometric parameters, the materials, and the span of our, specifically the girder that it's going to be used on this reinforced concrete floor. So we choose all these different types of elements, and in this case, we're just going to go ahead and add the dead weight of this specific joist of this concrete floor, and we just going to go ahead and calculate it. As we see here, it's going to be calculated, and it suggests, the program automatically suggests with which rebars are going to be adequate to verify this specific joist. As we see here, we have the drawing, we have all the options to see and to hide the different diagrams, to see the resistance, all the acting forces, all the combinations, deflections, and of course the combinations for cracking, because it's a reinforced concrete element. For other types of floors, the procedure is going to be quite similar. As we see here with the corrugated sheet, if we click on the calculate sheeting button, it's going to open a new window where we can set all the parameters of our sheet floor. So as we see here, we're going to select the span, and from the materials of the steel, we are just going to select one from the library, and for this section, we are just going to go with the default shading preloaded on the Thermoway program. Of course, the user can upload their sections as they want. As we see here, everything is set completely correct, and we are just going to go ahead and add the weight and drag and drop to calculate the sheeting. As we see here, the calculation is passed, and if we were to go back to redesign or redefine some of the elements that were already calculated, there is no problem about that because they have already been saved. As we see here, if we go back to reinforced concrete beams, we are going to see all the elements that we inserted and their current status, so nothing is deleted, everything is saved into the model. And of course, if we want to go back into the structure environment and we change something and we change some parameters, the local verification environment is going to be updated accordingly. So similar to corrugated sheet, it's going to be the calculation with steel beams and bolts. And if we go to columns, we are going to see several options on how to calculate a column. To calculate a column, the options are going to be quite similar to the ones that we already saw in the beams section. As we see here, if we click on the columns section, we are going to see the option to verify reinforced concrete columns, masonry columns, or steel columns. For every one of these elements of these columns, we can just create a new one. We can import it from the model by clicking on this option here, or we can just on the 3D view, right click on a column and select calculate to introduce it to the verification environment. So as we see here, for example, if we introduce a new reinforced concrete column, it's going to be quite similar. All the features are going to be quite similar in the sense that we are going to set all the parameters, and some parameters that are going to be specific from columns, such as the exposure class and the thickness of the lower and the upper slab. As we see here, everything predefined, it's correct, it's how we want it. And we can, if it's a new parameter, a new column, we need to introduce the different forces that are going to be acting on that column. In this case, I'm going to go ahead with a very simple input of forces just for a demonstration. And we can choose the forces at the top, at the bottom, and which combination do they stand for. So in this case, it's going to be for an ultimate limit state combination, static combination, and we're going to choose all the different forces that are going to be acting on that specific combination. I just click OK, and then after everything is set, I just go ahead and click on OK. So I just go ahead and drag and drop it from columns to be calculated to calculated columns, and very similarly as we saw earlier, it's going to verify all the parameters of the column. It's going to give me a safety factor. It's going to give me more information about which level is located, this element is located in. As we see here, 0 because it was created by the user and it's a new element. Here we can see that we have a suggested rebar input on this reinforced concrete column that if we want, we can change it. If we wanted to, we could change the horizontal rebars, or we can just change these stirrups. We can just change the stirrups in the central region and introduce a lower or an upper critical zone with a different specification on stirrups. As we see here, everything was drawn, and for our last step, we're going to see the drawing that we can export as a DXF. The case is going to be quite similar for masonry columns and steel columns. For masonry columns, as we see here, we're going to be able to add a name, different loads in different heights of the column, and we are going to see all the results once we inserted all the parameters. In the same way, we are going to proceed in a similar way with, in this case, steel columns. Again, we can just include all steel columns to import them from the program, from the structure environment, or we can just introduce a new steel column. In this case, we just first insert the geometry and the general parameters of the column, of the steel column. Then we have a space to introduce different combinations of forces, and of course the calculation parameters that are very important in the verification of steel elements. Again, once we insert it, we just need to drag and drop from steel columns to calculate to calculate the specific element. Regarding the footings, of course, we're going to have different input options, similarly as we saw with beams and with columns. We can just create a new footing and verify it, or we can import a footing from the structural model. There are two ways to import a footing. We can click on this icon here, on this element on the list, that it's going to include all the footings that are located on the structural model, or we can just simply right-click on the footing and right-click and click on calculate to calculate that specific footing. For this case now, I'm going to go ahead and show you how to introduce a new footing. In order to do that, we just click on new footing calculation and a new window is going to be open. In this window, we can select all the geometrical parameters, all the parameters really for this specific footing, which are going to be the section of the column, the geotechnical parameters, and in this case, the geometry that we can just introduce a new kind of geometry. I'm just going to go ahead and introduce a simple geometry with no eccentricity. And once we introduce the geometry, we can see the drawings in the lower left side of the screen. Also, we are going to introduce the forces that are going to be introduced by each combination. So we first need to select the combination type that's going to include those forces. And just for demonstration purposes, I'm going to introduce a very simple combination. Once we add it, we can add, modify, and cancel as many groups of forces, as many combinations that we want. So we just go ahead and click in OK, and as we see here, our footing was created, and very similarly to beams and columns, we are going to have a calculation card for each element that we just need to drag and drop into footings calculated for it to be calculated. As we see here, it automatically verifies different validations that are very important that are very specific and important for footings, such as we see here, axial bending, the load bearing capacity of the soil, the displacement verification, and we are going to see the safety factor. Once it's greater than 10, it's shown this way, so we know that the verification is passed. Also, we have information similar to other parts of the local verification environment, such as if this element was created by the user or if it's new, as we see here. And in the lower part, we see the rebars that are going to be needed for this specific footing with those specific set of load combinations. And if we want, of course, we can edit and we can change it if you want to do so. Once a footing is completed, we just can drag and drop it into footings completed. The Tremuri local verification module also offers some options regarding the calculation of walls. As we can see here, if we go to the allocated menu, we can see options regarding the calculation of lintels that can be made of steel or masonry. Once we click on the window, it's going to open a new floating window where we can insert all the parameters, the name of our project, and by clicking on calculate, it's going to perform all the selected verifications. We just go ahead and cancel that, and once we do a calculation, we are going to see the calculation card. It's going to be saved in the software. We can open or delete it, as we see, by right-clicking on the allocated window, and as we see here, we see all the details of that verification. This is going to be very similar for masonry lintels. Of course, we're going to see some parameters that are specific to that type of calculation, such as the materials used and the geometric data for the masonry lintel. And once we insert the parameters, the type of calculation, and the description, we can just go ahead and calculate. Another option regarding the walls inside Tremuri are the calculation of encirclements. As we see here, we can calculate a new encirclement, or we can just go ahead and right-click on a wall to calculate the encirclements of that wall. So we see here, we just click on calculate encirclements, and what this does is that it's going to open a new floating window that we're going to see a drawing, an elevation drawing of the whole wall, where we can calculate all the encirclements. This is going to retrieve all the information. It's going to import all the information from the structural model, being the geometric features and the characteristics, the materials, and also the forces acting on that wall, and it's going to be used for the calculation of encirclements. So as we see here, once we insert the name of this specific calculation and we click on calculate, we're going to see that it automatically calculates for different settings the encirclements of that wall. As we see here, we also have the option to introduce a comparison between the current status and the project status. In this case, they're the same. Once we click in OK, we just go ahead and close the window, and it's going to be saved in the model. As we see here, we're going to have information if this particular encirclement was created by the model, by importing data from the model, or created by the user, and it's going to show us if the verification is satisfied. One last option regarding the walls are the masonry infill walls. As we see here, once we click masonry infill wall, we can just insert a description, a name for our calculation. We can set all the panel constraints to calculate them, and the characteristics of the earthquake, and all the characteristics of the panel, giving the height, where it's located, the confidence factor for the material, the thickness, and so on and so forth. Once we click on calculate, it's going to perform both calculations, the resistance verification and a kinematic verification. The arch module inside Tremuri local verification allows us to calculate different types of masonry arches. As we see here, once we click the new arch calculation, it's going to open a floating window where we have to insert, first of all, the name of the arch that we're going to calculate, and then on the first tab we're going to insert all the geometric parameters of the arch that we wish to calculate. First, we need to introduce the shape of our arch. In this case, we've got three options of data input that are going to be: we can introduce all the geometric definition by inserting data from a table, or define it by the rise over the angle if our arch has a circular shape. In this case, we're going to go ahead and define it by rise. We are going to select also if our thickness is going to be variable or invariable. In this case, we're going to keep it constant. And then we just go ahead and introduce all the geometric parameters of this specific type of arch. So I'm just going to go ahead and, as an example, I'm going to introduce all the geometric parameters. As we see, the feeling about the keystone, the span, the rise, and the number of sections in which we're going to divide this arch. Once we insert the last of the geometric parameters, as we see here, in the lower part of the window, we're going to see an image of the arch that we just defined. Of course, we're going to define the material sections, as we see here, the masonry compressive strength that we are going to insert, the confidence factor, and we have the option to introduce a composite reinforcement in the extra dose or intra-dose or in both sides of the arch. In this case, we're going to go ahead with our reinforcement, and we can define further properties such as the ones needed for a seismic analysis. So you see here we're going to introduce the number of stories, the height, and the minimum impost height. So we just go ahead and introduce the loads. In this case, we are going to introduce the parameters needed for the permanent loads of our arch. In this case, we are going to introduce the specific weight, the specific weight of the filling, and the permanent non-structural loads. As we see here on the image below, it's going to be updated automatically. Later, we can opt to introduce the seismic loads for different limit states, as we see here, limit states of life limit states or collapse limit states, and also we can introduce variable loads. We have two options. We can introduce them with a table by introducing the data imported directly from Excel, or we can use our graphic input here that it's going to help us to introduce our loads more quickly. As we see here, we just go ahead and introduce a new graphic input, and with the help of the snap, we're going to be able to decide exactly the length of this new load. If it's a variable load, we can define different beginning and ending points. As we see here, we're just going to make it constant for now. Just click OK, and our variable load has been added successfully. Then we are going to start with the calculation. We have, given the fact that it's a masonry arch calculation, we have the options of insert different cracking settings, and we can go ahead and compute the thrust line. Once we click, the program automatically calculates the thrust line and also calculates on a vast array of diagrams that are going to be very useful for the design, such as the axial force, the shear in each section of the masonry arch, and the bending moments, one for each section. Also, we're going to see the different stresses for intrados, extrados, and the shear stress. Also, we are going to be able to visualize the moment normal stress diagram by clicking on the allocated icon, and we're going to be able to see the safety coefficient without reinforcement. Later, if we want to continue with the calculation, we can perform a kinematic analysis by computing the mechanism. In this case, since we don't have reinforcement on our masonry arch, we are going to see this side of the table empty, but for the load safety factor for the unreinforced case, we're going to see all the corresponding parameters. Same with regarding the seismic loads, we're going to be able to compute the mechanism. So we see in a matter of seconds we have everything calculated and the hinges located on the masonry arch. One last calculation that is possible in this module is the nonlinear kinematic analysis. As we see here, what this does is going to give us a detailed evolution of the collapse mechanism of this masonry arch. We just click and it's going to create the graph with different accelerations and displacements. And over here, we're going to see how the collapse mechanism evolves through the different steps of the curve. As we see here, we have the option of introducing reinforcements to compare how they're going to impact on the design and the safety factor of our masonry arch. Once we finish with our input, we just go ahead and click OK, and our calculation is going to be saved within the model. Lastly, one of the features inside the local verification module is the utility menu. Inside the utility menu, we have a vast array of verifications that are possible to be made that are going to be, in some cases, independent from the rest of the model, which is going to give us more detail, and we're going to have more possibilities alongside with the integration of the model. We are going to be able to calculate things independently and to keep everything inside Tremuri. As we see here, we have verifications that can be made for reinforced concrete, such as the shear verification, bending or axial bending verification for different section types, the cracking verification for reinforced concrete. Also, in the case of reinforcements, we can verify them with bending, axial bending, and shear verifications. Regarding the loads, we can calculate and set new loads that are going to interact with the structural environment if we want to, such as the floor loads, wind, and snow. We can perform all the tests regarding the concrete tests that are made inside. Regarding the steel connections, we are going to be able to calculate different types of very complex weldings. In timber connections, we're going to be able to calculate different types of connections, such as the ones made of carpentry or the ones made with nails, screws, and bolts. In the geotechnical sections, we're going to have two options to calculate. We can perform the calculation for pile, or directly we can use the K-Winkler calculation. On the fire menu, we're going to be able to perform the fire verification with different types of elements in the flexural verification type and the axial bending verification type. We also have a section to calculate different water tanks, different types of water tanks and their verification. And we can also have an allocated section where we can calculate the reinforced concrete beams, or the ones, let's say different types of beams, such as reinforced concrete beams or steel and wooden beams. We can calculate the local seismic response, and we have lastly a menu where we can calculate different types of dowel bars. Thank you all for your attention. Don't forget to follow us on social media to get all the updates on the Tremuri software.